I'm going to show you how you can have a wave and a particle at the same time. You will even be able to visualize the solution. I've shown this to several physics professors at different universities, and they could not see anything wrong and encouraged me to pursue this concept. A light beam does not have mass when moving in a straight line relative to an observer. I am proposing that when a light beam moves in a curve relative to an object or the observer, the curving of this light beam creates the characteristics of mass from that observer's point of view, although this would be very little mass. I know that we are told that light has no mass and always travels in a straight line, following the curve of space. But what if we considered two different ways of viewing space? First, I want you to think of relativity and how two observers can see the same event differently. From the viewpoint of curved space, the light is still traveling a geodesic and therefore in a straight line. But from the viewpoint of the observer on the planet, the light is curving, and from what I am proposing, curved light has mass. What if the fabric of space is electromagnetic waves? Let's play with this idea of curved electromagnetic waves and look at the repercussions. From the point of view of a planet, the light beam is curving and has mass. The amount of mass that we are talking about when a light beam curves around a planet is incredibly small. The planet just sees something curving in relation to it. So from the planet's viewpoint, that something must have mass, since it appears the planet is pulling on it. This would also mean that from the planet's point of view, the curved light beam is also pulling on the planet, however minutely. Let's look at a curving electromagnetic wave. If a slight curve starts to show the beginning of mass characteristics from the observer's viewpoint, then an increase in the curvature would mean more mass characteristics from the observer's viewpoint. More curvature means more perceived pull and more perceived mass. While from the viewpoint of space, there would be no observed curvature or mass. The maximum curvature would be when the electromagnetic wave forms not just a circle, but the smallest possible circle. This is when we would see the most mass characteristics. An electromagnetic wave circling with a circumference of its wavelength would no longer appear to us to have wave characteristics, but mostly particle characteristics. This is what we currently call a particle. I use the term characteristics because we are always talking about an electromagnetic wave. There is no magical transformation from matter to energy. There's only a geometric transformation between curved and straight motion. If you imagine an electromagnetic wave with the speed of 300,000 kilometers a second, moving in a circle the size of a quark or a proton, you can see how it would appear as a solid particle. There are several variables that need to be considered when you want to understand the physical properties of a circling electromagnetic wave or particle. These include wavelength, frequency, amplitude, and circumference. Now I'll show you how to visualize wave-particle duality. To do this, we will use movement and different points of view. Here we have a video camera recording a particle from the side. Now assume that the particle is not actually what we currently think of as a particle, but an electromagnetic wave that is traveling in a very small circle. We will now see how it can be both by using different video camera viewpoints, observing the same circling electromagnetic wave. In the first setup, the video camera will move at exactly the same speed and direction as the circular electromagnetic wave. If you watch the video recorded from the video camera, you will see a stationary particle from that point of view. In this setup, the video camera will be stationary and the circling electromagnetic wave will move across the screen. If you watch the recorded video, you will see a wave traveling past the video camera. In this setup, the video camera will move past the stationary circling electromagnetic wave. If you watch the recorded video, you will see a wave traveling across the screen. We can note here that if there is any movement, whether it is the circling electromagnetic wave or the observer, we start to see wave characteristics. In this setup, the video camera will move at half the speed of the circling electromagnetic wave. If you watch the recorded video, you will see a mixture of a circling electromagnetic wave and a wave. It will be both a particle and a wave at the same time. So is it a wave or a particle? It depends upon the relative viewpoint of the observer and the characteristics of the wave. Since the electromagnetic wave is moving at 300,000 kilometers per second, then even if the circling electromagnetic wave is trying to move in a straight direction at 3,000 kilometers per second, most of its movement would still be circling, and it would still be 99% particle characteristics and only 1% wave characteristics. If the circling electromagnetic wave was trying to move in a straight direction at 297,000 kilometers per second, then most of its movement would be going straight, and it would have only 1% particle characteristics and 99% wave characteristics. And very importantly, this is relative to the object and the observer. An observer moving past a circling electromagnetic wave would see different characteristics than an observer beside that same electromagnetic wave. Strong particle characteristics will typically be derived from the electromagnetic wave being stationary in relation to the observer, circling with a minimum circumference, having a high frequency, high amplitude, and short wavelength. I imagine a gamma ray moving in a circumference of its wavelength to have extremely strong particle characteristics. Strong wave characteristics will typically be derived from the electromagnetic wave moving in a straight direction in relation to the observer, having a low frequency, low amplitude, and long wavelength. I imagine a radio wave heading out to space having mostly wave characteristics. Let's look at the double slit experiment. The energy equivalent of one photon is sent through the slits. The electromagnetic wave has particle characteristics as it sits in the particle gun, but as soon as it is given a shot of energy towards the detector, it travels in a straight line and therefore takes on wave characteristics. When the electromagnetic wave's energy is captured by the detector, it can no longer move in a straight line. This introduces one wave of extra energy into the entire system of the detector screen, with the energy spread out all over the detector. Nothing can be recorded or detected at this point in time until a quantum of energy gathers in one place. Here's how you can picture this happening. Imagine you had a perfectly even bucket of water completely full to the edge, so that absolutely no more water could go in, not even a drop. This is a stable system. If you sprayed the equivalent of one drop of water from a spray bottle directly into the bucket, the spray would become diluted in the bucket, but since the bucket is full to maximum, quickly a drop of water would have to form and fall over the edge of one part of the bucket. The chaotic nature of the huge number of molecules of water and their movement would mean that the drop could spill over the edge at any point of the bucket rim. And this drop would not be made up from the same molecules that were originally sprayed into the bucket. The detector is designed similarly. It absorbs the energy temporarily, but it is designed so that it cannot retain the extra energy. It kicks out the excess energy that can be viewed or recorded. Just like the drop of water, the wave of energy shot from the photon gun eventually gathers in one place and is detected in that spot with the energy of the full wave. This gathering of excess energy happens incredibly fast, around the speed of light in a small area. Now let's spray the equivalent of one drop of water from the spray bottle and have it come out in the shape of a flower. You would increase the chance that the drop of water that falls out of the bucket would be closer to one of the thicker parts of the petals, because there would be more water already in those areas, although it could still drop out of the bucket at any point. Because there is so much motion, energy, and variables from all the molecular movement in the water, you could not know exactly where each drop would leave the bucket. After time, though, you would see a pattern of more drops where the petals were closest to the edge, simply because of statistics. When you record where these drops came out of the bucket, you will notice this wave-like pattern. Even though each drop came out in a random place, over time this wave pattern forms. Remember, the drop of water that was in the spray bottle is not the same drop of water that falls out of the bucket. This is similar to the screen in the dual slit experiment. It records where the energy has gathered, and this does not mean that it is the same wave of energy that was shot out of the gun. Since the electromagnetic wave travels in a straight line from the gun, it is a wave, and hits the screen with an interference pattern. There's a greater chance that the excess energy will gather where the energy already is, and be recorded or viewed on the screen where the peaks of the wave hit. Of course, the full wave of energy could gather anywhere. Through chaos and statistics over time, a wave pattern will appear. Particles already exist, and it would be very difficult to get a straight electromagnetic wave to curve into a circling electromagnetic wave. In other words, to create a particle. I can only see this happening under extreme circumstances, like a black hole. A particle accelerator could create such extreme circumstances where electromagnetic waves curve or circle after a particle collision. However, we do see examples of particles or circling electromagnetic waves breaking down into energy or straight electromagnetic waves. Examples would be radioactive decay or just burning something, radiated heat. This makes me believe that a circling electromagnetic wave is in a higher energy state than a straight electromagnetic wave. If you're wondering about particle accelerators, this hypothesis does not conflict, because the accelerator is isolating a circular electromagnetic wave as if it is in a bubble and moving this bubble with the electromagnetic wave still circling continuously inside. Energy is continuously added to keep the bubble moving. This is in contrast to what we've been talking about. Our particle gun in the double slit experiment only added initial energy that changed the direction of the circling electromagnetic wave to a straight electromagnetic wave. Regarding quanta, if you think of a standing wave, you can understand how a wave traveling in a circle can only be stable in exact wavelengths. For example, an electromagnetic wave with a wavelength of 1 micron would only be able to travel in a circle with a circumference of 1, 2, 3 microns or any other whole number. It could not travel in a circle of 1.1 or 1.5 or 2.8 microns because the wave would interfere with itself. This explains why there are quantum characteristics in particles. Except for a black hole, pick any point in space and imagine floating there. Now look around and what do you see? Most likely stars or something where there is some kind of light. But even if you were at some point in the universe where perhaps you can't see stars, you could get a telescope and you would be able to see them. Pick any other point in space and do the same. No matter where you are in space, you will always be able to detect electromagnetic waves. So what does that mean? Every single point in space is filled with an incredibly large number of electromagnetic waves at all times. It means that space is filled with energy in the form of electromagnetic waves. We know there is a gravitational force that affects our entire galaxy. This would mean that all light or electromagnetic waves traveling through our galaxy will have a slight curve. If we follow this hypothesis that curved light takes on characteristics of mass,
then we should have a large amount of matter in our galaxy. This would not appear like matter to us, because it would be 99.9999999% energy and only 0.0000001% matter. But it would be in every bit of space. An unseen matter. You might even call it a dark matter.
But what is space? We are told that it is something but nothing. It is emptiness, yet it curves, bends, and folds. What if the fabric of space is all of these electromagnetic waves at every single point? We now have something we can define and even curve, bend, and fold. Electromagnetic waves don't curve because they are following space, they curve because they are space. Electromagnetic waves create the fabric of space like water creates an ocean with underwater currents. The only premise that I'm asking you to consider is that an electromagnetic wave gains mass characteristics when it curves. If that is the case, then the rest of what I've just proposed followed in a logical manner. Everything is a percentage wave and a percentage particle. A straight gamma ray has more mass characteristics than a straight radio wave, even though they are both moving at the speed of light. The world we experience is mostly in two categories: 99.99% wave characteristics and 0.01% particle characteristics for what we call light or energy, and 99.99% particle characteristics and 0.01% wave characteristics for what we call matter. There is no magical transformation between matter and energy. The change in percentage of characteristics is the geometric transformation between the amount of curvature and moving straight. In the dual slit experiment, we never really work with the particle. We add energy to a full stable detector, and we see the energy exit in one spot, falsely believing that spot is where a particle had hit. When particles or circling electromagnetic waves move to straight electromagnetic waves, they are moving from a higher energy state to a lower energy state. This causes a transference of particle characteristics to wave characteristics, which is really only a geometric transformation of curved motion to straight motion. This hypothesis with a simple basic premise makes a lot more sense to me than a belief that we have infinite parallel universes and multiple realities. If this wave-particle duality hypothesis is correct, then there are so many new and exciting discoveries and paths that can be taken from these basic concepts. I've applied the circular electromagnetic wave concept to everything I can think of that's relevant, and it always seems to fit or provide a reasonable answer. I believe this will open up a new way to think about the universe. I'm hoping someone out there knows of a way to test this hypothesis. I do not know of all the physics tools and apparatuses available to design an experiment, but I'm hoping that someone out there might inform me of possibilities after watching this. The last, and maybe the most important concept that I will leave you with, is that all we would need to create our entire universe are electromagnetic waves. Electromagnetic waves that curve to form matter and forces, and electromagnetic waves that are straight, that give us energy. Thanks for watching.